Now, to understand this, think about a function that looks like this. Okay, this is a function that slopes like this. Now, think about a value x. Let's let that point be x. At that point x, the y would be the function of x, which is fx, isn't it? Okay, fx, which is the y coordinate of that point x. Now, let's consider some value h. Okay, let's consider some value h that can vary. Okay, h can vary. So if that length is h, this x coordinate would be x plus h, isn't it? But this would also vary depending on what h is, right? So if this is x plus h, the y coordinate of this x value would be this one here, which is fx plus h, isn't it? Okay. Now let's consider this length over here, just that length over here. This length would be this full length minus that length, right? Which is going to be fx plus h minus that length, which is fx, isn't it? Which is what we have here. Fx plus h minus fx. That's the length of this. Okay, now let's consider gradient, because differentiation refers to gradient, okay, at a singular point of any function. Okay, so remember in your previous years where we learnt gradient as rise over run? Hope you guys remember that. See how the rise is this length here, which is fx plus h minus fx, over the run, which is h, isn't it? So h, that's what we have here, fx plus h minus fx over h. And we refer to gradient as the change in y over the change in x, isn't it? So this is what we have. Now to be more specific, let's go on to something as a differentiation notation. This dy over dx is the derivative notation, the differentiation notation, and which is also commonly noted down as f dash x. Okay, these two are the same thing but different forms of writing it. Okay, but they mean the same thing, derivative of a function. Okay, so if you see this, it means we're deriving something, derivative of a function equals to, now this bit I'll explain on over here. Can you see that? Remember how I said h is some changeable value? So let's say h is this length here, and there's a point there and there. But remember how I told you that with derivative of a function, we like to find the gradient of a function at one singular point, right? At a singular point. So, but here we have two different points, right? So if we're trying to find the gradient of that point, if I draw a line through those there, that's the gradient. But see how what we like to do is get closer to that point there. See how this is a bit far away? So what I like to do is bring the h a bit smaller, because see, say for example, if the h is just up to there, that would be the point y, and if I draw the lines through that, see how it's getting, the length of these are getting shorter, the gaps are getting shorter, and it's coming closer to that particular point. So say if that h was almost closer to 0, the gradient would almost be there, wouldn't it? Which is almost like a tangent to that curve, right? So, but it can't be 0 because we never have denominator 0, but we want to know when h is really, really close to 0, so we have almost the accurate gradient, okay? So that's why we have this limit sign here, limit h tends to 0. Remember how I told you h arrow 0 means h tends to 0? So it's not exactly 0, but it tends to very close to 0. So limit h tends to 0 of, remember the gradient I told you just previously, fx plus h minus fx over h. Okay, so yes, this is something you must memorize. This is our notation of the first principles, and yes, you do have to memorize this because sometimes they ask you to exactly use this first principles to answer a question. Okay, so hope that makes sense. I know it looks a bit confusing, but hopefully my questions will get this stuck in your head. Okay, so let's go on to example 1. I'm going to use the first principle notations. It's asking us to differentiate fx equal to x squared from the first principles. Okay, and this is the first principles, right? f dash x, or you can write dy over dx if you like, that's fine, both are the same thing. F dash x equals to limit h tends to 0, fx plus h minus fx over h. Try to read it again and again to get that in your head. And if it doesn't say from first principles, you don't have to use this all the time. Okay, we will learn a different rule that we will do much shorter way. but if it doesn't mention this, you don't always have to do first principle, just remember that, okay? Now, it says differentiated from first principle, so, and this is the function, fx equals to x squared. Okay, now I'm going to apply this function onto this notation. So what I'm going to do is use that, starting with something like this, okay? And guys, an important thing here is to keep that limit sign there, keep that following your simplifying form until you get to the final answer, until you actually sub in h as 0, okay? Because otherwise you will get marked down. Okay, so limit h tends to 0. See how fx plus h means we're going to put x plus h into wherever there's x, right? Okay, so if fx equals x squared, fx plus h would be x plus h squared, right? That's why I put x plus h squared here. Okay, so whatever's inside the bracket, you're going to replace that with the x, okay? With the x, you're going to replace x plus h in it. So it's going to be x plus h squared minus fx is simply x squared, isn't it? So I put x squared over h. Okay, so I hope that makes sense. Trying to understand that. All I did was sub the inside values into that function. Now let's simplify. And again, I'm going to keep my limit sign following. So I'm going to go like this, keep my limit sign. Now expand the numerator. So x plus h squared is x squared plus 2xh plus h squared, and it's simply negative x squared. This is just expanding a quadratic over h. Okay, now let's gather some like terms, and you can see that the x's, they actually cancel itself, don't they? So I'm going to cancel those, and we're left with 2xh plus h squared over h. And again, I'm still going to keep my limit sign, okay? I'm just keep stressing this to you because this is important as well. So now that I've done that, let's factorize by h, okay? Because h is the common factor on the numerator. Factorize by h, and you can see I've got h, 2x plus h, this is inside the bracket remaining. Now you can see that h, these are common, numerator and denominator, so I can cancel those like that. So what do we have left? We have limit h tends to 0, just that part, 2x plus h is left. So now we can't simplify any further. This is when we sub in h is 0. Okay, so I'm going to sub in h is 0. If h is 0, it's just going to be 2x plus 0, which is just 2x. And that's the answer to example 1. Okay, does that make sense? So see how when I subbed it in, I no longer have the limit sign, so that's when you can take that away. And that's the answer. So as long as you memorize this first principle rule, basically the rest is kind of like algebra, okay? So be really careful. That's example 1. Let's move on to some questions similar to this. So question 1 says differentiate fx equal to 3x squared from first principle. So again, it says first principle, so I'm going to use my first principle notation, this one here. Okay, so trying to memorize as we go. So again, I'm going to use this with this function this time. The function is this time 3x squared. Okay, so let's apply it onto here. So it's going to be something like this. So I keep my limit sign, limit h tends to 0. Now, see how it's fx plus h? So wherever there's x, I'm going to replace it with x plus h. So x is there, so I'm going to have 3 times x plus h squared, and that's what I have there, minus 3 fx, so it's going to be 3x squared, okay, just like as it is. So 3x squared, so whatever's inside the bracket, I put it into there. Basically, that's all you need to remember it as, over h. Okay, so I've just subbed in everything in. Now all I need to do is simplify that. Now let's expand it all out. 3x plus h squared becomes 3x squared plus 6xh plus 3h squared. Guys, if you like, you can add some extra steps in, okay? You don't have to do everything at once. Trying to expand x plus h first, x plus h squared first, go x squared plus 2xh plus h squared, and then you can, on your next step, you can expand with the 3, okay? Don't try to rush it because you need to be really careful with this one, all right? So don't rush it if you can't do it properly. So now negative 3x squared is just negative 3x squared. Okay, so that's how I expanded it over h. Alright, now I can see that I can have 3x squared minus 3x squared, which is actually a good thing. I can just cancel them out, can't I? Okay, so now what's left? We just have limit h tends to 0, 6xh plus 3h squared over h. Okay, can you see that? So again, you can see I'm always having my limit sign. Okay, now what I'm going to do is factorize by h, because again, h is a common factor. So take out h, I have 6x plus 3h. Now can you see that h is on top and bottom? I can just cancel it, and what do we have left? We just have limit 6x plus 3h. Okay, can you see that? So now we can't actually simplify any further. All we can do is just sub in h as 0. So to sub in h as 0, 3 times 0 is just 0, so 6x plus 0 is just 6x. So the derivative of this function is 6x. Okay, that's our final answer. And see how I no longer have limit sign on our final answer? And that's it. Okay, so I hope you're kind of getting the hang of this now. I know the working is a little bit long, but see if you can understand. So question 2 says differentiate fx equals to negative x squared from first principles. So again, we're going to use our first principles. Okay, so it says limit fx plus h. So trying to understand this, for those who are still confused, trying to have a look over here. Basically guys, what fx plus h means is whatever's inside the bracket, we're going to replace it with wherever there's x. Okay, so I'll just write this again. I won't include the x. Let's just write it without the x's. I'll just leave it blank. Equals to negative squared plus 2. Okay, it's basically like this, isn't it? Okay, I mean, it doesn't always have to be x. It could be p if it wants to, right? So what I'm going to do, whatever's in here, I'm going to put it all into here as well. Okay, so say this is like 100. These will also be 100 as well. Okay, but this time it's x plus h, isn't it? So if I put x plus h into here, then all of these would be x plus h as well. Okay, so this is x plus h, this is also x plus h. Alright, that's the kind of thing you got to consider. If you're really unsure, try to do what I'm doing here, okay, until you get used to it. Alright, so basically wherever there's x, I'm subbing in whatever's in here. Okay, what's in here? X plus h, so I subbed in all wherever there's x as x plus h, just like this. Okay, I'm going to do that here. See how this first part here, which is the corresponding one of fx plus h, is exactly what I have over here, isn't it? The first part. Can you see that? That's what I'm doing. So you may like to use some big brackets as well. Now minus, okay, it's going to be fx. Fx is basically just this one here, just this one, yeah? Which is just going to be negative x squared plus 2x. Okay, so that hopefully fx is a bit simple. Okay, now that's over h. Alright, everything's over h. So now all we need to do is simplify. Okay, so let's simplify. Yes, it's going to be a lot of expansion. Be really careful. And it's going to be negative x plus h squared. This as well. You may like to add some extra steps in if you need to. X plus h squared is x squared plus 2xh plus h squared. And then on your next step, you may like to expand with your negative, okay? And if you do that, you're going to get negative x squared minus 2xh minus h squared, all right? And then it's going to be 2 times x, which is 2x, 2 times h, which is 2h, okay? Now negative x squared is positive x squared. Negative positive makes negative, so negative 2x, and that's whole thing's over h, all right? Now let's see if we can cancel anything out. Okay, you may like to use some shapes if you need to. So see how these x squares, this is the same, but with different signs, so I can actually cancel them. Anything else that I can cancel? See how this one here, I'll use triangles this time. See how this one, 2x minus 2x, they would also cancel, won't they? Right? So let's see what we have left. We just have negative 2xh minus h squared plus 2h left, and that's all over h. Okay, and make sure you keep your limit sign. Now what can we do? Let's factorize by the common factor, in this case, which is h, isn't it? H is the common factor. Take it out. Here we have negative 2x minus h plus 2 left inside our brackets. And you can clearly see that again, we can cancel these out because they're the same. So we have left with limit h tends to 0 just inside the bracket. Negative 2x minus h plus 2. Okay, so now we can't simplify any further. So what I'm going to do is sub in my value of h, or 0. Okay, I'm going to put 0 into h. So we're just going to have negative 2x plus 2 left. Okay, because h is just 0, it just disappears. So our final answer is negative 2x plus 2. Okay, and that's it. That's our derivative using first principles. So I hope that makes sense as well. So basically, guys, if the subbing in fx plus h, if that's difficult, try to do something like this on some separate paper if you need to. okay, because it will help you until you get used to it. Okay, so that's question 2. Question 3, it says differentiate fx x plus 1 squared. Okay, so this is our function this time from first principles. So let's use this again. All right, so again, we're going to do fx plus h. Okay, so I'll do the same thing over here. So for those who are still confused, it's going to be f. I'm going to leave the x blank. I'm going to leave inside the brackets blank. It's going to be, I'll use some bigger brackets, plus 1. Okay, so because the x is inside the bracket, I just used bigger brackets and I put the x as little bracket over there. Okay, so now whatever I sub in here, I'm going to sub into here as well, aren't we? So see how it's going to be fx plus h. So if I sub in x plus h into here, this will also be x plus h. Okay, so we're going to start with x plus h plus 1 squared, which is the same thing as this, x plus h plus 1 squared, which is exactly the same as what we have here, right? Okay, and then fx is just x plus 1 squared, which is that fx. So I have negative and then x plus 1 squared. Okay, and that's over h again. Now we need to expand. We're going to expand like this. So yes, it's a bit long. See how x plus h plus 1 squared, you may like to write it out as x plus h plus 1. And I'll write this out. And then times x plus h plus 1, and you may like to do one at a time following this. Okay, just try one at a time. Okay, it's a big expansion, so you've got to be extra careful. So once you've done that, you should get x squared plus h squared plus 1 plus 2xh plus 2x, okay, plus 2h. Okay, it's a long expansion, just be really careful. Okay, now we've got negative x plus 1 squared. Okay, and again, you may like to add some extra steps in because it's got a negative outside. You may like to expand the x plus 1 squared first by x squared plus 2x plus 1, and then expand with the negative on your next step. So if you expand, you're going to get negative x squared minus 2x minus 1. All right. Okay, that's all over h. Okay, it's a long one, so be extra careful. Let's see if we can cancel anything out. Okay, I can see that the x squares, I have an x squared there and I have an x squared there, but they're opposite signs, so I can just cancel them, can't I? Which is a good thing. And I can also see that 1, there's another 1 here. So I like to cancel that, okay? Because it's 1 minus 1. Okay, now I've got 2x, negative 2x, cancel it, cancel. Okay, so this is always the fun part. Okay, now that we've got that, let's simplify down to what we have left. So I've got h squared plus 2xh plus 2h, the whole thing over h. Okay, and again, please keep your limit sign. Now, I hope you're getting the pattern now. Now we're going to factorize. See how h is the common factor for all three? So I'm going to take h out. We have h plus 2x plus 2 left inside our bracket. And as you can see, we can clearly just cancel those out. Okay. So what do we have left? We have limit h tends to 0, h plus 2x plus 2 left over. Okay, and our final step is to, now that we can't simplify any further, we'll sub in h tends to 0, or h is just 0, so into there. So it's going to be this. Because that's 0, we have 2x plus 2 left over, which is our final answer. That's our solution to question 3. Okay, yeah, it is a bit long. After you apply your first principles, you've got to be really careful with the expanding out, okay? So please take extra consideration for those. Okay, that was question 3. Let's move on. Question 4, differentiate fx equals to x cubed from first principles. Okay, so this time our function is x cubed. Okay, so we're getting different functions each time. And again, let's use our first principles. I hope this one is a bit easier for you to interpretate, because this one is x plus h. This is x cubed, so if it's x plus h, it would be x plus h cubed, right? So trying to understand that, it's x plus h cubed because that's x. Now I do minus fx. Fx is just x cubed, so I do minus x cubed. Okay, and that's all over h. All right, so now let's do some expansion. It's going to be like this. X plus h cubed, yes, you've got to do some extra working out. Expand it all out, you should get x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed. Okay, and that's all over h. Can we cancel anything? Yes. This one and this one we can cancel because they're opposite signs. So what do we have left? We have 3x squared h plus 3h squared plus h cubed all on h. Okay, and I hope you can see that h is a common factor, so we can factorize by h. So we have 3x squared plus 3xh plus h squared left inside. And again, we can cancel. Okay, so what do we have left? We have 3x squared plus 3xh plus h squared left, which is the thing inside the brackets. So can we factorize any further? No, we can't. We can't even simplify it. So what we're going to do is just sub in h is 0 and it becomes just 3x squared. Because see, these all have h's in it, so these all become 0. So all we have left is 3x squared. And that's the answer to question 4. Okay?